So in this video, I'm just going to show you how to find the general solution of a differential equation like the one given below. dy by dx is 2x brackets y plus 4, where y has to be greater than 0. Now, in this case, we've got a differential equation because we've got a derivative, we've got an equal sign, we've got variables. So that meets everything we need for a differential equation. Now, to find a solution of a differential equation, we ultimately want to end up with y equals something. So the first thing I'm going to do is I'm going to do what we call separating our variables. And separate our variables, that just means we want to get the y's on one side and the x's on the other. So the first thing I'm going to multiply through, so I'll just write that down, separate variables. I'm going to multiply through by dx. So that's going to give me dy is equal to 2x multiplied by y plus 4 multiplied by dx, like that. Now, what we do need to do now is obviously remove the y plus 4 from the right-hand side. Because it's part of that multiplication, I'm going to divide through. So I'm going to write it in a very specific way, which will become obvious shortly. 1 over y plus 4 dy is equal to 2x dx. Now, the reason I've done that is I could have written dy over y plus 4, but I want to separate out the two expressions. Now, we need to think of a way of getting rid of that dy and dx now, so we're just left with y's and x's. Now, we've seen something like this before, and I can do a mathematical operation to both sides, as is the law in algebra, as long as I do the same thing. And what I'm going to do is I'm going to integrate both sides. And during that integration process, the dy and dx will then disappear. Now, in part 1, we looked at some standard integrals. And standard integral 1 over y plus 4 will integrate to the natural log of y plus 4. And 2x would integrate to x squared. And I'm going to put one constant of integration on the right-hand side. Now, obviously, there should be a constant on both sides. But what I'm going to do is I'm going to gather those all up and I'm going to put them on one side because a constant plus a constant is just a constant. Now, what I need to do now is get rid of that natural log. Now, you should know from Unit 3 and Unit 1 that the inverse operation of natural log is exponential. So if I raise both sides of this equation to the power e, I should then be able to cross those two functions out, the exponential and natural log. That's going to leave me with y plus 4 is equal to e to the x squared plus c. What I'm going to do now is I'm going to use some laws of logs. And if you remember the addition law, if you have a to the power of b plus c, that's exactly the same as a to the power of b times a to the power of c. So I'm going to do this with this function here. So that's going to give me y plus 4 is equal to e to the x squared times e to the c. And that just separates out our constant from our variable. Now, e to the power of c is just another constant. So what I'm going to do here is I'm going to write a is equal to e to the c. So I don't have to keep writing that in my calculation. So now what I've got is I've got y plus 4 is equal to a e to the x squared. Then all I need to do is take away 4. So I get y is equal to a e to the x squared, take away 4. That is my general solution